In today's class, emphasis will be on power. We want to discuss power. It's a concept that we've been talking about it on a daily basis. We want to understand the physics perspective what power is all about. Power simply means the rate at which work is done. The rate of doing work is what we call power. The rate at which energy is expended. Now, let's look at this scenario. We have two people here, A and B. Want to give these two people a task and want to know who is more powerful. Assuming this A looks smaller than B, and then you have given them maybe a bag of rice to lift. The bag of rice is here for each of them to lift. And then want to know who will lift it faster or who will complete the task faster. All of them will complete, but the fastest person is that person that is more powerful. Maybe it takes A 30 seconds to lift. It takes a B 10 seconds to lift. So in this regard, we can say that B is more powerful than A. So mathematically, we can say that power is equal to work done all over time taken. So we can write this as power equal to W all over T. Recall, we have defined a work done as force times distance. So if this is equation 1 and this is equation 2, if you now substitute equation 2 into 1, we can now say that power is equal to F times S all over time. So in this case, this is distance, this is time. And we define speed. Recall that speed V is equal to S all over T. If this is equation 3. So by the time you substitute equation 3 into equation 2, we substitute this into this, we can now say that power is equal to F times V, where F is the force and the V is the speed. Now, what is the unit of power? The unit of power is watts. Watts. So we know that 1 kilowatts is equivalent to 10 raised to the power 3 watts. 1 kilowatts is equivalent to, 1 megawatt is equivalent to 10 raised to the power 6 watts. And 1 gigawatt is equivalent to 10 raised to the power 9 watts. And we know that 1 horsepower is equivalent to 746 watts. So all these are the units of power, but the SI unit of power is watts, the SI unit. So we have a problem here to solve. Physics, once we talk the theory, we must use that theory, the background of the theory, to solve a problem. A car is moving at a constant speed of 10 meters per second. The force retarding its motion is 200 Newton. Determine the power of the engine required to maintain its motion. Like I will always say, if you are given a problem, first of all, you list out the parameters. So in this case, force is given as 200 Newton. And what again? Speed is given as 10 meters per second. So what are you asked to calculate? Power. Therefore, power is equal to F times V, which is equal to 200 times 10, which is equal to 2000 watts. So, if you are asked to calculate power and you are given force, you are given force and speed, this is the formula you use. But if you are given, you have power, this work done, sometimes you be given the work done directly and the time. So you can use this to calculate your power.